Okay, so last night we talked about measures of center. We talked about mean and median, and we talked about one measure of spread, IQR. So tonight we're going to talk about another measure of spread, standard deviation. So let's talk about where standard deviation comes from and what the heck it means. So here I have today's data set. It's 17 14-year-olds from the UK. So how do we find the mean? Well, we use the formula for mean. Right? N is 7 because there's 7 kids. And we would just add them up and divide by 7, and we'd get 24 centimeters. Remember, always include units in AP Stats. Always, always, always. So I want to talk about what it means, what mean really represents. And so I'm going to put these data points in. I got 28, 25. So I'm just going to do a dot plot with the 7 data points. And sometimes it's hard to see how things balance. And one of the cool things that happens with mean is if you take the data set and you just start moving everything towards the center. Let me just make sure I put that up right. I got 2 24s, a 25. Oh, there's 2 25s. Sorry. And so can we see if that's balanced? So there are 7 data points. 1, 2, 3, 7 data points. So how do we balance that? Well, the rule is we just move stuff towards the center. So if I move this one towards the center, I move this one towards the center. If I move this one towards the center, I move this one towards the center. And we just keep moving stuff. Uh-oh. We just keep moving stuff, one on opposite sides towards the center, and what'll happen is all the data points will always stack up on the mean. The mean is the center, the numeric center of the data. And understanding that will help us understand where standard deviation comes from. Because what standard deviation is measuring how far things away from the center and then finding a quasi-average of that. How far is each data point away from the mean? But remember, the mean is the mathematical center. And then can we average this? So let's look at if it's possible to average these numbers. So let's take our data set here. And we know that x bar here is 24 centimeters. And so each one of these really should have centimeters on it. And so how far is each one of these data points away from the center? So 25 is 1 away from the center. 22 is -2, and these are all centimeters, right? And this is how far each one of these data points is from the center. The problem being, though, that we're going to run into is when we add them up. If we add all those values up, if you do 1 plus -2 plus -4 plus 1 plus 0 plus 0 plus 4, they always add up to 0. And they add up to 0 because of this. Right? For every one that's 1 on the right, there's going to be one that's 1 on the left, and they will always balance out. And so that begs the question then, well then how do we average them if they always add up to 0? And so there's the one that all the students want to do is take the absolute value of all of those and add them up. And then you could do that, and that gives you something called mean absolute deviation. The problem with mean absolute deviation is all the theory for stats, all the stuff that we're learning, the proofs for that, the high-end math that makes it all work and that links all these concepts is using calculus. And it's almost impossible to do calculus on absolute value. And so someone said, okay, well, we need another function that if we have a negative number, it's going to turn into a positive. And if we have a positive number, it'll stay positive. And then someone said, well, what about quadratics? If we square all the terms, then they'll all be positive. And so we can do that. Now we can add up all the deviations and get a number. Now, you would think you would then just divide that number by 7, the number of students we had. But in fact, and if you really have some extra time, you can go online and look at this. is there is somebody who was working for the Guinness Brewery who did a whole bunch of high-level math and decided that you should prove that in a sample, if it's a sample, you divide by n minus 1. And you'll get into a whole thing about degrees of freedom that's really beyond the scope of this class, and how he published his work anonymously while he was working at Guinness, so Guinness wouldn't steal it. It's a fun side story, well worth your time for some summer reading. But for us, we just need to know that if it comes from a sample, we're going to divide by n minus 1. And so we'll do this. The problem, though, is if we come back to this, and I bring this back up, is that if we square anything, the units on all of these are centimeters squared. And now we're comparing distance from the center here. But we're doing distance with a formula for centimeters squared, which is area. And so while we have a nice formula for the variance, it's hard to relate back to the original thing we were measuring, which was the average foot size. And we said the average foot size of the 7-year-olds is 24 centimeters. It was foot size, wasn't it? Let me look at my original data set. Yep, foot length. So the average foot length is 24 centimeters. Okay, well, on average, how far is each one of those away from the center? Well, it's in centimeters squared, and that makes no sense. So in order to get a measurement that makes sense, is we take this formula for the variance, and we take the square root of it. And then this also takes the fact that the number is exaggerated by squaring them in the first place. And so what we would do is we'd take 38 divided by 6, right? Because this was the sum of all the deviations. This is n minus 1, and we take the square root of it. This is centimeters squared. And when we do that, if you want to check that in your calculator, you will get, if you do this in your calculator, right, this was 38 divided by 6, and this was centimeters squared. So we would say the variance is 6.3 repeating centimeters squared. So to find the standard deviation, we're going to take the square root of that, and we will get a standard deviation of 2.512, I'll just round, centimeters. A word about rounding on the AP exam. Generally round to 2 decimal places. There's no hard, fast rule because later in the season everything's going to be approximations and you know, real close. And so they don't sweat it in AP Stats like they do in AP Calculus. So about 2 decimal places is generally going to be okay. So what this is saying is that we said that our center was 24 centimeters, but, and I'm, you know, air quotes here, on average, they are, each data point is about 2 centimeters away from the center. So the more spread out the data is, the further things are away from the center, the larger the standard deviation is, the tighter packed they are, the smaller the standard deviation is going to be. Now, a word of warning here. I'm sorry about the... is that the standard deviation of a sample, we use S sub x. For standard deviation of a population, we use sigma. And sigma has a slightly different formula. Instead of dividing by n minus 1, you're dividing by n. But rarely in AP Stats are we going to be asked to find the standard deviation of an entire population. And we're going to learn how to do both of these on the calculator. So most of the time when you're doing it, 99.9% of the time in class, we're going to be finding, if you're asked to find something, it's going to be the standard deviation of the sample. So which do we use? Oh, just to go back, one more thought. So if it's a sample, we use x bar, and if, you know, sample is x bar and standard deviation of that. And then if it's a population, then it's mu and sigma. And those are the notations. And so we got to look at, is our data set a sample or is our data set a population, so that we write the right variable. And if we make this mistake on the AP exam, if you use the wrong symbol, they assume that you don't understand the difference between a sample and a population, which means that you don't understand stats at all. And generally that'll cause the entire problem to be wrong. So what we've learned is we've learned two different ways to do center and spread. We've learned mean and median, and which we should use. We learned about how to find the quartiles. We learned about the interquartile ranges. We learned about how to identify an outlier. We identified how to create the 5-number summary, and then how we can show the 5-number summary using a box plot. We learned today about variance and its square root, the standard deviation. And, you know, we learned that back here, which I think is what you use. So this point, this last point here, is if you have a skewed distribution, you want to use median and IQR. If it's a approximately symmetrical distribution, then you want to use mean and standard deviation. And we're going to do a lot tomorrow in class exploring those and why you use one over the other and what happens to data. And so I'll see you guys whenever next class is.